Alright, good evening students. So today we move on to the next part of the chapter, something called the law of surds. Okay, now under surd, the concept, before we move into the concept itself, okay, now let's look back at numbers. Now, I'm sure you've heard of rational numbers. Okay, rational numbers, as we know, are numbers which can be written in the form of decimal as well as fraction. Okay, that means you can convert it in both ways, either from a decimal to a fraction or from fraction to a decimal. So usually rational numbers are written in this form. You're talking in form of a fraction where a over b and b is not equal to 0. Okay, so example would be, let's say you have got 0.5 which can be converted to half. Okay, so this is one example of it. All right. Okay, then on the other hand, you've got something called irrational numbers. So now, irrational numbers is the opposite of rational numbers, will be decimals that cannot be converted to a fraction. Okay, this one can, whereas this one cannot. So usually, when you have fractions, example, let's say fractions of this is actually, if you're talking about 0.33333, and it goes on and on and on. All right. Okay, now coming down to the concept of surds. All right, so surds are actually, I'm sure you have seen this form. Okay, surds are actually infinite decimal. Surds are you can say fractions which has got infinite decimal places, and they are non-recurring digits, numbers. Okay, so normally surds can be written in this form a. Okay, this is called surd a order n. So this is surd of a to order n. All right, so example, let's say you have got surd 5 order 4. Okay, so this is one example of a surd. All right, so for further information, you can actually refer to page 96, from page 96 to 97 in your textbook. All right, so coming back to surds, surds have non-recurring decimals. So far they are called, so that is why they're known as irrational numbers. Okay, all right. Okay, so we take an example. Okay, let's see. We have got this number. I want to see whether I can actually convert this to a fraction. So I've got 787878. Okay, so I want to see whether I can actually convert this to a fraction. So if I can actually convert this to a fraction, meaning it is actually a it's not a rational number. So let's say we introduce n as 0.7878. So these are actually recurring decimals. So now what I'll do is, the next step is I'll multiply this by 100. So you actually get 100n. So it means on this side, if you multiply it by 100, you get 78.7878 all the way. So I'm going to call this equation 1. This is equation 2. So next step will be equation 2 subtract equation 1. So equation 2, equation 1, so when you subtract, you'll actually get 99n. And here, what you'll actually get is 78. Meaning now my n becomes 78 over 99, which can be simplified further to become 26 over 33. Okay, so meaning that this decimal can actually be converted to a fraction. Okay, so this is 1. Now let's say you have got, okay, This is your first example. Let's say another example where you have 3.757575 and so on. Okay, let's assume I call this, okay, now this is A. So now A can be written as, now if you notice this is my recurring decimals, so I actually put it as 3 plus 0.757575 all the way. So now let's assume this is my n. So A is actually 3 plus n. So now I'm going to move on to n, just like what we did previously here, to see whether I can actually get it in the form of a decimal. So 757575, so on. So I multiply this by 100. So I actually get 75.7575 and so on. Okay, same thing. Equation 1, this is my equation 2. So it's 2 minus 1. So I'll actually get 99n, and this will be 75. So n becomes 75 over 99. So this can be simplified as 26 over 33. Sorry, so 25 over 33. All right. Okay, so now coming back to my question, I'm looking for my A. So A is actually 3, this one, 3 plus n. So A becomes 3 plus 25 over 33. So this can be written as A is 325 over 33. All right. Okay. So these are two examples where you have got recurring decimals. Okay. Now coming back to the concept of surds. Okay, we want to know whether a given number is a surd or not, because this is the second half. So here, what I've done here, the first part here, is actually the concept of rational numbers. Okay, so now we move on to this surd. So what is surd all about? Okay, surd are numbers where you actually get decimals and the decimals are not recurring. So take an example. Now let's say I've got this. I'm sure you've seen this before. Cube root of 27. So cube root of 27 is actually 3. We get exactly 3. So this is not a surd. Okay. All right. Now let's say I've got root 64. Cube root of 64. So it becomes 4. So this is also not a surd. Alright? Okay, we try one more. Let's say 127 cube root of this. So when you actually check it in the calculator, you'll actually get 5.02652 and so on. Okay, so it's continuous and this is non-recurring, so therefore this is actually a surd. Right? Okay, so we take one more example. Let's say 1125 power 4 root of 4. So we'll actually get 5.7914 and so on. So this is also a surd. Okay, all right. So one last example. Let's say 6. This is 64 over 729. So you work this out. So you'll actually get 2 over 3. Okay, so this is also not a surd. All right. Okay. So these are two concepts that we've seen today. One is the concept of surd, and this would be how we convert recurring numbers to fractions. Okay, so as a short practice, I want you to do this. Self-practice 4.3. Number 1 and 2 is on page 99. Okay, your assignment for today. Thank you.